Hello, this is Mr. Huff, and let's talk about this diagram a little bit. So we're looking at sewer slope. There's a couple of things in your notes. It talks about how you have to have at least 2 feet between the first floor and the top of your drain pipe, and the bottom of your drain pipe, actually the top of your drain pipe needs to be below the frost depth as well. And we are mostly interested in the elevation at the bottom of this pipe. So let's look at this. We have a building drain, and we're looking at the change in elevations divided by the distance from the building to the main. So we have the building here and the main septic line here. So here is our sewer lateral. This is the drain that runs from the house to the sanitary sewer connection in the street. The sanitary sewer connection is the main in the street, and so here we see a cross section of a large pipe. We have a clean out here. Plumbers will use this to access the drain line here so they can clean out roots and debris and that sort of thing to if there's blockage. And we're interested in maintaining a flow from the house to the sewer main. So some elevations we are interested in, they're called invert elevations. The first one is the bottom of the drain at the house, and then the center of the sewer main, because we expect that the pipe is connected so that the bottom of the pipe is about lined up with the center of that main. So we're interested in that elevation, the center of this pipe here. And then the difference between those two is our elevation. The other distance we need is the distance from the edge of the house to the center of the sewer main. We'll call that the distance from the building to the main. All right, looking at this slide, there's a lot going on here. I really like this version of the formula because it makes the most sense. So let's talk about this. So we're looking at the invert elevation at the building. That's the bottom of this pipe, minus the crown elevation. Then the crown elevation is the invert elevation of the sewer main plus the outer diameter of the pipe. So we're looking at what's the elevation of the top of the sewer main. Okay, that's what the crown elevation is. And then we're going to subtract half of the outer diameter of that pipe. Okay, so we have the elevation at the building minus parentheses the crown elevation subtracting 1/2 of the outer diameter of the pipe. So if this was a 20-inch pipe, we would be subtracting 10 inches from that. Okay, what they do in this formula here, and it's a little hard to follow after they do this, is they distribute the negative into these parentheses. So you're subtracting the crown elevation and adding the outer diameter. Mathematically, both of these are the same. I like this version in the middle because it's easier to understand. We're looking at the crown elevation and subtracting the outer diameter of the pipe, half of it. Okay, so that takes us to the center. Let me know if you have questions about that. So calculating this, you would identify these values: the inverse elevation, the crown elevation, and 1/2 the outer diameter. All of these need to be in feet, and then divide by the distance from the building to the main. Okay. And that's all I have to say about that. I'll probably work through an example just